All right, number 35, we've got this function for -1 to 5. Find the x-intercepts, sketch the graph, and write down the gradient at 2. This is all with graphing calculator. Okay, so clear this stuff. And then we're going to put our function in, which is 3x minus e to the x minus 2, and then minus 4. Enter. I'm just going to zoom out a bit. Okay, so this is from -1 to 5. So we need to get the endpoints by tracing. So -1, enter. So that's going to be down there at -8.45. So remember, don't go outside of your domain. So about here, and I would label it, but I'm not going to do that right now. And then we need to 5, enter. So 5 negative 9.09. So about there. And then we just need the x-intercepts, which is analyze graph 0. So we've got 1.54, which is about there. And then we've got 4.13. So labeling all of this, which is like there. And then we need the maximum, which is 3.0, 3.1, 2.3. Oops. So 3.1, 2 point, like there. And then we will connect those in just a second. So we found the x-intercepts, we sketched the graph. Now, last thing, I'll connect that in a second. Write down the gradient of the graph at x equals 2. So we need to go menu, analyze graph, dy dx, and then we need 2, enter. So the gradient at 2 is 2. The other thing I forgot was the y-intercept. So it's about here. So now I can connect smooth curve like this. And so we've got f prime at 2 is 2, sketch the graph, and the x-intercepts, should have labeled them. All right, now we need the derivative of f. So that's going to be 3 negative sine 2x times 2. So negative 6 sine 2x. And now double I. Find the values when the derivative is 0. Give your answer in terms of I. So we've got negative 6 sine 2x equals 0. Divide by 6. Negative 6 is still 0. Then sine 2x is 0. Change the domain. And then sine is 0 at 0, pi, 2, pi. And then we have 0, pi over 2, and pi for a double I. Now find, the function g is that. The graph of f can be transformed to the graph of g. So f to g by a stretch in the x direction with scale factor 1/2. So that's this one, followed by another transformation. So that is going down 1 in the y direction. Describe fully this other transformation. So it's a vertical translation down 1, okay? And then find the solution to the equation 1 plus 3 cosine 2x equals g. So we need to substitute 2x in. So 2 times 2x is 4x, and then we subtract 1 because of that. All right, so those 1's go away. And then we have cosine 4x minus 3 cosine 2x minus 1 equals 0. And it says with graphing calculator, so I'm definitely using that. So I put this into the graphing calculator, and the first x-intercept I get is 1.05. And then I get 2.09, but this is only good to pi over 2. So this is our only answer, okay? Now, I was just looking at the answers. All right, 37. The following diagram shows a water wheel with a bucket. The wheel rotates at a constant rate in an anti-clockwise direction. The diameter is 8. The center of the wheel A is 2 meters above water level. So that means that this bit, if the diameter is 8, the radius is 4, so that has to be 2. After t seconds, the height of the bucket above the water level is given by that. Show A is 4. Okay, so the height here above water level, so this is about water level. So our minimum is -2, and above water level is 6. So if we do A is the max minus the min over 2, that's 4. So the wheel turns at a rate of 1 rotation every 30 seconds. So now we have 2 pi over, and it's in seconds, so we can use 30. That's pi over 15. That's B. Now, in the first rotation, there are 2 values of t when the bucket is descending at a rate. So this is, when the bucket's over here and it's going down at a rate of 0.50 meters per second. Find these values of t. So the function is 4 sine pi over 15 t plus 2. So we need the derivative, which is 4 cosine pi over 15t times pi over 15. And we want to set this equal to 0.5. And just a second, because all right, so wait, it says 1 rotation every 30 seconds. So if the bucket is starting there, I don't know, we'll have to see if it's going to be -0.5, where the bucket's starting. I was going to say if the bucket's starting here, then it has to be after 15 seconds, because it takes 30 seconds to go all the way around. We'll see. So I'm going to put this in the graphing calculator. Okay, so when you can't put 0.5 for 2 reasons. So first of all, we've got, this is the thing, and when I put in 0.5, this first intersection is 1 point, maybe not. It's before 30, it's before 15 seconds. And then this one is 25 point whatever. So we only have one intersection there when the rate is 0.5. So when I put in negative 0.5, there's 2 times. And also you can't put in 0.5 because you don't know where the bucket starts. So these two answers are 10.6 and 19.4. 10.6 and 19.4. Determine whether the bucket is underwater at the second value of t. So we want to do the height at 19.4 into the regular this function, okay? And since when you do that, you get negative 1.19, you know it's underwater because if this is 0, you know, it's down here at negative, the height is negative 1.19. Okay, so here I sketched this graph on the graphing calculator. This is all the stuff you would want to include. I've got all the x-intercepts. I've got the y-intercept there. I've got the maxes. I've got the mins. And I've got the endpoints. Okay, so that's all the stuff you want to include. The amplitude, so we can do A is equal to the max, well, I think you can see, minus the min over 2. So that's 10 over 2, 5. The period, so if we have, so the x-intercept between negative pi, hold on. So this one, the x-intercept between negative pi over 2 and 0 is the negative 0.927. The period is between, I'll just do a min and a min. So we have 3.78509 minus a negative 2.49809. Okay? And when you do this in the graphing calculator, you should recognize it's 2 pi. So that's the period. All right, so if we want to write it in that form, we're going to have, so for C, so we have the amplitude is 5 and sine, and then remember if it's this, you do this first and then this. So we are moving to the left 0.927. So this is going to be plus 0.927. And then our Q is just, should be 1 because our period is 2 pi. So that should be our answer. And write down one value of x such that the derivative is 0. So that's, we want a horizontal. So you can pick any of the max or the mins. So this could be negative 5.64 or 0.644 or negative 2.498 or 3.785. So that's all D. Write down the two values of k for which the equation f at x equals k has exactly 2 solutions. Well, that's just down here at the minimum, okay? So k is going to be negative 5. Like here we have 4 solutions. Here we're going to have 1, 2, 3, 4, 5 solutions. So, let g equal that. There's a value of x between 0 and 1 for which the gradient of f is equal to the gradient of g. Find this value of x. So you guys can do this by hand. And I will show you another way in the calculator. So let's see. So g derivative is 1 over x plus 1. And we have f derivative. I'm just going to use the original one just because we rounded that 0.927. So this is going to be 3 cosine x minus 4 sine x. So we can set these two equal to each other and then find that intersection. Okay, so I put in those derivative functions, the 3 cosine x minus 4 sine x and the x plus 1. So they want to know x is 0 to pi. There's a value of x between 0 and 1 for which the gradient of f is equal to the gradient of g. So we're looking for an x in between 0 and 1 where these graphs intersect. This is at negative 2.62. That's not it. That is negative, but this one is the one we're looking for. That one, 0.510725. So that should be the answer. Now, the other way to do this, which I learned semi-recently, sadly. So what you can do, you might not have this opportunity, but if you do, you can actually go to this little button here and do this one, okay? So the derivative with respect to x of your original function, so 3 sine, oh shoot, not there though. Okay, here. 3 sine x plus 4 cosine x. So the original function. Okay, so this is graphing the derivative. All right. Now, we can graph also, so tab, and then this one, ddx. So the derivative with respect to x of natural log x plus 1, graph it. And now we just need to find when these two intersect again. So analyze graph, intersection. So that one is that negative number, we don't need it. This is the one we want, okay? So that's the answer, 0.511.